Forces and equilibrium. We're first going to start with a couple of review terms. When we talk about a vector, we're looking at a quantity that is fully described by magnitude and direction. So some examples might be 30 meters per second east or 5 miles north. Notice that both of those quantities have a number or a magnitude, and they also have a direction. And we would represent them graphically with a vector arrow pointing in the direction of the particular quantity. Scalar quantities. A quantity that is fully described by magnitude alone. So a scalar quantity does not have a direction. So some examples might be 5 meters, 20 degrees Celsius, or 256 bits. A net force. A net force is the overall force acting on an object. When we talk about our Newton's first law of motion, we know that an object at rest stays at rest, and an object in motion stays in motion. When forces are balanced or they cancel out, an object in motion stays in motion, and an object at rest stays at rest. If the forces do not cancel out, then an unbalanced force exists. The net force is the vector sum of all forces acting upon an object. When we talk about equilibrium, equilibrium is when all the forces that act on an object are balanced. We say that the object's in equilibrium when this is true. If an object is at equilibrium, then the forces are balanced. Thus, the net force is 0, and that helps to explain Newton's first law. If an object is at rest and the net force is 0, it's going to stay at rest. If an object's in motion and its net force is 0, it will stay in motion at a constant velocity.